If you're a Java developer, you have definitely faced this classic dilemma. When do you use an interface, and when is an abstract class the right call? They seem kind of similar, but picking the right one is absolutely key for writing clean, scalable code. So, in this explainer, we are going to break it all down and give you the confidence to make the right choice every single time.
So let's start with the big picture. How do we actually build software that's not just powerful, but also flexible enough to change and scale over time? Well, the answer isn't just in the lines of code you write, it's in the design choices you make right from the get-go.
And the secret to that great design? Well, it often comes down to one of two core ideas. You either start with a strict contract that says what a class has to do, or you start with a flexible blueprint that gives it a solid foundation to build on. And you guessed it, that's exactly what interfaces and abstract classes are all about.
Here's the game plan. We'll kick things off by talking about what a contract really means in code, which is the perfect lead-in to interfaces. Then we'll get to know their slightly more flexible cousin, the abstract class. After that, we'll put them head-to-head in a showdown, and we'll wrap up with a super simple guide on how to choose the right one for your project.
All right, let's dive right in. First up, interfaces. You can think of an interface as the purest form of a blueprint you can get. It's all about defining a set of rules, the what, without getting bogged down in any of the implementation details.
So what is it really? An interface is basically a pure contract. It's just a collection of method signatures with no code inside them. It tells any class that uses it exactly what it has to be able to do, but it gives zero clues on how it should do it. That part is entirely up to the class that implements the interface. And why would you want to do this? Well, there are three huge reasons. First, you get total abstraction, which means you're hiding all the messy implementation details. Second, and this is a big one, it's how Java lets you get around the single inheritance rule. It's the key to multiple inheritance. And third, it helps you write loosely coupled code, which is just a fancy way of saying your code is more modular and way easier to manage down the line.
Okay, let's talk keywords, because this is important. As you see here, a class extends another class to inherit from it, but when a class uses an interface, the keyword is implements, and that word is a promise. It's a signal that your class is signing the contract and is guaranteeing it will provide an implementation for every single method defined in that interface.
And this right here, this is the superpower of interfaces. In Java, a class can only extend one other class. That's it. But as this diagram shows, a class can implement as many interfaces as it wants. It can be a vehicle, and serializable, and flyable, all at the same time. This is how Java gives you the power of multiple inheritance, and it is a total game changer for flexible design. Okay, we've got interfaces down. Now let's meet the other side of the coin, the abstract class. If an interface is a pure empty blueprint, then an abstract class is more like a flexible foundation, a starting point that's already got some of the walls built for you.
An abstract class is kind of a hybrid. You declare it with the abstract keyword, and right away you can see the big difference. It can have a mix of methods. Some of them can be abstract, just like in an interface, forcing any subclass to provide its own version. But, and this is key, it can also have regular, fully implemented methods, providing shared code that all its children can use right out of the box.
Now, there are a few rules of the road here. Just like an interface, you can't create an object directly from an abstract class. It's not a finished thing. It's meant to be a base, so another class has to extend it. But unlike an interface, it can have things like constructors to help set up subclasses, and it can even have final methods that its children are not allowed to change. All right, we've met both players. Now it's time for the main event, the showdown. Let's put interfaces and abstract classes side by side. This is where it all comes together and the differences become crystal clear.
The most fundamental difference is this right here. An abstract class gives you the freedom to provide some shared default behavior, some actual code that all its subclasses can inherit. An interface, on the other hand, is traditionally 100% abstract. It's a pure contract. Now, I should mention, since Java 8, interfaces can have default and static methods, which kind of blurs the lines a little, but the core design philosophy is still very different.
This table really lays it all out. Don't worry, we're not going to read the whole thing. Let's just hit the highlights. Look at that row from multiple inheritance. See that? Not supported for abstract classes, but it's the bread and butter of interfaces. That's a huge deciding factor. Now look at variables. Abstract classes can have all kinds of member variables, while interfaces are stuck with public static final constants. And finally, access.
With abstract classes, you can have private or protected members to hide parts of your implementation. With an interface, everything is public by default.
Okay, this is the part you've been waiting for. We've gone through all the theory, so what's the payoff? Let's build a simple, practical guide for making the right call when you're actually writing code. When do you use which?
It really just comes down to asking yourself a few simple questions. First, think about the relationship between your classes. If you have a group of tightly related classes, like a dog and a cat are both types of animal, then an abstract class is probably a good fit for sharing that common animal code. But if you're just defining a capability that lots of unrelated things might have, like the ability to be clickable, that's a job for an interface. And finally, here's the knockout rule. If your class already extends another class, or if you need it to inherit from multiple blueprints, you have no choice. You must use an interface. At the end of the day, neither one is better than the other. They're both incredibly powerful tools for building clean, abstract code. It's all about picking the right tool for the right job. So, as you design your next feature, your code is going to tell a story, and you get to decide, will you write it with a strict contract or a flexible foundation? The choice is yours.